So record. Aha, beautiful. Now share screen. This is the whiteboard. Okay. So this class today is super easy. In my opinion, the second test is easy. In my opinion, the third no, and the fourth no. Well, the second yes, it's super easy.
The board is up.
Do you see the board?
Yes, sir.
Okay. Basically, is the linear system of equations and their applications. Can only system equation, inequality, in linear, non-linear, but no. Okay, we start at the beginning, the easy part. The easy part is linear and equality. Good afternoon. Very well this. Okay, entonces, let me recall. I suppose you remember, but I want to recall. We have two methods for solving this. One method is called substitution. Another is called elimination. But no, let's focus in substitution now. After elimination, we have time to practice. The substitution, what's the key idea of substitution? The substitution is you take either equation, but I prefer the easier equation. In my opinion, the easier equation is number 2. And you solve for x or for y. Okay, substitution is good when the coefficient of the one equation is 1 or -1. See, it's not like that. You can, of course, but this is a little bit complicated because you introduce fraction and you complicate your life. But in this case, you take, for example, the equation number 2. Again, copy. This is the number of the equation, number 1 and number 2. I like to numerate like that because maybe we have several equations, number 1, number 2, number 3, number 4, number 5. So from now, I start numeration 1, 2, 3. So you take the second equation because, in my opinion, I consider it as easier equation. And solve for x or solve for y. In this case, solve for x because the coefficient here in front of the x is 1, no? So say 4 plus y. And you take now this expression and replace 4 plus y x and another equation. So you replace maybe here. Look. Okay? No in the same, no, the same no, because in the same you don't find anything. In the another equation. Says no x anymore. You copy 4 plus y plus 2y equals 0. In that moment, we have one equation, linear equation, with only one unknown, easy piece, okay? We combine like term, 3y, 7, 3y is equal 7 minus 4. I move 4 to the right hand side, fraction, 3 divided by 3 both sides, y1. Now, in order to find another value of the x, you can substitution in either equation. In the equation number 1, and the equation number 2, but I prefer in the equation number nothing, que es this equation, que is waiting for me because x is isolated. X is equal 4 plus 1, x is 5. And the solution set is the only pair 5, 1. Remember, the first component is x and the second component is 1. Equation. Super easy. Easy. You remember very well. Question. Come on. Opinion. Hard, complicated, professor. I don't understand anything. Complicated or easy?
It's okay.
Okay. Let's do another example. Bring me new situations. Example 2. Example 2 is 3x minus 2y equal to, this is equation 1, 4x minus y is equal 5. 2. And I consider this is the system. No? So this curly bracket indicate me that this belongs to the system. And the thing we are doing now is solving the system. I try to find the solution of the system. Okay, by the way, is find the order pair x comma y such that satisfy both equations. Suppose that the set of the equation you plug in the equation number 1, true statement, and the equation number 2, true statement. You have several equations, 1, 2, 3, you satisfy true, 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 true. Okay, because this is a system. This is forming like a mathematical object, okay, system of linear equations. Okay, in this case, I select again the second equation because in my opinion is easier, and also coefficient here is -1. This is fantastic. For example, I copy 4x minus y equal 5, okay. So it's 4x minus 5 equal y. I move y to the right hand side. I move 5 to the left hand side. And this expression, I substitution here. Look. Right? And another equation. Wow, wow. Pulling off microphone. Any microphone off, please. Can you copy now? Ah, sorry, I make a mistake. This guy is not 3. This guy is 8. Fix that. Let me check in 2y, 4x. Ah, it's okay. That's the only mistake. So it says 8. So you copy ax minus 2 parentheses because this y is this expression. These 2 multiply everything inside the parentheses. It should be equal to. Now it's a algebra, basic algebra. You apply distributive property to remove the parentheses. Negative become positive 10. No? But wow, look at that. What amazing, suddenly weird situation happened when this and this is canceled out because the same, it's 0, disappear. Wow, it's gone. And you get this statement. It's completely wrong. It's completely false. Statement false. And that means that we have no solution. This system have no solution. It's equivalent to say that the solution set is empty set. You can write using that symbol. You need to be familiar with this symbol. Or like that, open the curly bracket, but nothing inside. No solution. Okay? Sometimes happen that when you try to solve it, you discover, no, we have no solution. How do you know that? Because the variable disappear, it's canceled, it's gone. We cannot solve for x. No, we cannot. However, you get completely false statement. That means no solution. Everyone follow me? Follow me?
Yes, sir.
Yes, sir.
Absolutely. 3x
Going.
minus
Professor,
y.
can you go back up for a second?
For the second example?
Yes,
Okay, go ahead.
thank you. I got it. You can go on.
What are you doing? You took a picture?
Yes, I screenshot it so I can copy it down.
Very well, very well. Equal -2, equation 1, and 6x minus 2y.
He's like, whose mic is that?
Well, what that?
And I'm like, oh, sir, I'm sorry, it's my.
It's okay. Putting off the microphone to avoid that situation. Okay, we continue using substitution. In this case, in my opinion, I using the equation number 1 because coefficient here is -1. They take advantage of this, no? It's -1. Because I copy 3x minus y equal -2 and solve for y. In this case is I move y to the right and 2 to the left. 3x plus 2 equal. And you take this expression and substitution in another equation, this equation number 2, no? This equation here. and you copy 6x minus 2 parentheses 3x plus 2 equal negative 4. Sure. Okay, again, I apply this triviality property because I want to remove the parenthesis because my goal is solve for x. And you copy 6x minus 6x minus 4 equal negative 4. And again happen that this x is cancelled. We can't solve it. However, we get a true statement. It's a true statement, completely different to this. This was a false statement. But in this situation, we have solution, but we have infinity many solutions. We have infinity many solutions. But I need to clarify this because in college algebra or in intermediate, you leave it like that, and that's it, no more conclusion. But in pre-calculus, no. In pre-calculus, you need to understand much better that. I propose you doing this analysis. So one analysis case, graphic interpretation is extremely important. Graphic interpretation is extremely important. So I prepare for you in Desmos one interpretation of this problem. So I want to see now 1, 2, and 3. 1, 2, and 3. Let me see. Let me go to Desmos. Okay. I want to switch it to Desmos. Switchy, Desmos. Window, switching window. Okay, there you go. Okay, this is the example 1. The example 1, remember, was this is the system, x plus 2y equals 7, equation number 1, x minus y equals 4, equation number 2, and we discover in a piece of paper that the solution is 5,1. In this case, it's obvious it's a linear equation in 2 dimensions, in x or y plane. Therefore, each equation represents geometrically one line. So the blue represents the first equation, the green represents the second equation, and the intersection, look, is the common part that share both equations is the solution. In this case, you have only one solution, unique solution. The solution is 1 point. Okay. Now, in the equation number 2, we can see that we have no solution. Why? The reason is because we have 2 equations. I copy the equation, the first one in black color, the second one in red color, but we see, wow, they are parallel. Therefore, never meet. Therefore, never have common point. Therefore, we have no solution. Okay? Parallel, no solution, no common point. And the third one, look at what happened. I copy my green equation, look at that. I copy my blue equation, and they are a perfect coincidence. Look, blue, green, blue. Okay. We have solution, yes or no? No, we have solution when they're perfect coincident. Let me come back to the board to explain this in detail. Yes, we have solution. When you have common point, we have solution. When you share at least 1 point, we have solution. Let me prove how you represent the solution. So we have solution, definitely, yeah, we are rich. We have infinity point solution. Okay. However, basically the graphic representation was quickly one line like that, and another line in green color was exactly coincident with this. Entonces my question is infinity. But what means infinity? Infinity, for example, this point is solution. Yes or no? This point. A solution. This point. This in black color. Yes, a solution or no?
No.
No. At this point, a solution.
No.
At this point, a solution.
Yes.
At this point, a solution.
Yes.
Yes, at this point, a solution. We have infinity solution, but on this line. Entonces, how you represent this? Analytical. Solution set. Well, solution set is infinity, I agree. XY point such that satisfy this equation, that y equal 3x plus 2. And we need more extra idea. And where come from 3x plus 2? Remember, what's this? Okay, by the way, we get exactly the same answer after we explain. And very important, this is the equation, but I suppose in my mind that x is the independent variable and y is the dependent variable. So we have one variable that is totally free. You can assign an arbitrary number. X is totally free, for example. And y no, because y must be matching with this equation. So you represent like that. Look, you represent solution set is y equal 3x plus 2 and x is all real numbers. Another possibility, another way, common way that we using throughout the chapter is x comma y, such that y is equal to 3x plus 2 and x is free variable. Free means we have no limitation, no restriction. It's completely all real number. From negative infinity to positive. From negative infinity to positive. However, why no? Why? In this case, is from negative infinity equal, but under this formula. Under that formula. Okay. Maybe one question can fly in the air is one of professor. What is the? We can write always like that. No. There are several possibilities. Suppose, for example, you take the. Suppose another student take the second equation. And solve for y. Entonces, minus 2y is equal to minus 6x minus 4 and divided by negative 2 because I want to solve for y. We have y is equal to negative positive 3x plus 2. Same relationship. Doesn't matter what equation you select, it's the same. That means, guys, that these equations are depending. This is the new concept, depending. Depending means it's the same equation. One shortcut to see that is, suppose I copy again the equation. Suppose I copy again the equation. If you multiply the equation number 1, the entire equation number 1 by 2, in this case, another example, maybe it's another number. We have 6x minus 2y equal to negative 4. It's exactly the same to the equation number 2. Therefore, this is totally depending. And when it's depending, we have solutions, but we have infinity many solutions. Entonces, another concept behind this new idea is that you need to understand a little bit, because it's hard, complicated, is the dimension of the solution set is 1. Why? Because the solution is a line. And the dimension for the line, is 1. Dimension for the plane is 2. Dimension for the point is 0. Suppose this dimension of the solution set is 1. In the first example, look at that. In the first example, on the second example, we have no solution. So we have no sense to talk about dimension for the solution set because we have no the empty solution set. However, in the example number 1, the dimension of the solution set is 0 because we have just a point, 1 point. 1 point have no dimension. In this case, one line, yes, one line have dimension 1. And by the way, guys, dimension because is a line. I want to complicate, I promise, more your life, because when you study different variable, 3 variable, 4 variable, so we have a plane or hyperplane. But in this case, no, it's 2D, the problem, no? One more thing I need to say. Yeah. And the dimension, K1, is exactly the amount of free variable. How many free variable we have in that problem? We have, look at that, only one, K6. X is free, and the other is not free. But this is 1 because is X. So some student asked me, no, professor, but I don't understand very well. You can express it in another way. You can. Another possibility is, let me show you. Suppose my equation, the state relationship between X and Y is this equation. So another student say, well, okay. You declare because you want X is independent and Y is dependent. Okay. Y, this is a convention, this is always the same, no? No, you can declare in opposite direction. You can declare Y is free and X dependent of Y. So you solve for X in this equation, Y minus 2 divided by 3 is equal X. So you declare X is equal Y over minus 2 divided by 3 and Y is free variable. It's another possibility to write exactly the same. This and this is the same thing. Express it in different, they are equivalent. This and this are equivalent. Equivalent statement. But okay. This is completely crazy, completely wrong. No. I recommend you, you follow in the order of the alphabetic order, no? X is the first free, Y is the second free, C is the second free, and so on. In alphabetic order, right? And after the C, we have maybe Greek letter, no? Everyone follow me with this confusing idea. Free variable, infinite dependent solution. You have some idea how it look like that in the other algebra, or you never see before. Hey, some comment. I want to hear some comment. All right, I want to see your face. Everything is clear so far?
So far, so good.
This is important. This chapter number 2 and the next chapter number 3 basically is equation, linear system of equation, linear or non-linear. Okay, you need to be strong. This is super important in pre-calculus. Okay, let me go to the board. Okay, I have another example that bring me a new situation. Suppose this example 4, no? Example 4 is 3x minus 4y equal 1, equation 1. 2x plus 3y equal 12, equation 2. And this is the system that the reason I put together like one mathematical thing we need to solve it, no? Thus I want to use an elimination method. Elimination method is good. It's good. In my opinion, it's the best. In my opinion. Substitution I apply not frequently. I apply when you have variable the coefficient is 1 or -1, but The coefficients are 3, -4, 2, and 3. No, much better elimination. I propose one idea. If you multiply, for example, I take advantage. What is the idea for elimination? The idea for elimination is to have same coefficients, for example, -12 and +12y. And when you add in this, 0. Okay? Is the idea. This is the idea for elimination. And then I take advantage when there's the same number. I take advantage when there's opposite sign, no? To elimination. In this case, we have opposite sign, negative and plus. So I propose if you multiply the equation 1 by 3 and the equation 2 by 4, what is the idea? The idea is 3 times 4 is -12 and 4 times +3 is +2. This is the only possibility we have? No, of course no. Another student say, bueno, professor, this is the idea for elimination y, but if I want to eliminate x, you multiply, for example, the first equation by -2 and the second equation by +3, no? We go -2 times 3 is -6 and 3 times 2 is +6, ready for elimination now. Okay, I prefer the first way because I take advantage this part and this part have opposite sign. So let's do it. Multiplication, the entire equation by 3. The entire equation 1 by 3 is 9x minus 12y equal 3. And this is my equation number 1 again. It's the same, it's equivalent. Remember, when you multiply by a number, the line in 2D is the same line. It's the bending equation. It's the same. No difference. And when you multiply by 4, the second is ax plus 12y. That was the intention of the elimination equal 48, no? 48 was the multiplication, 4 times 12. Now I put a line like that, you combine 17. This is cancel. That was my intention. Cancel out that part. And this is 51. By 17 both sides. X equal 3. Okay, I have in my hand at least x value. I need to find the y value. The y value may be use substitution in the equation 1 or in the equation 2, whatever you want. Si you consider it gets better equation 1, let's do an equation 1. Si you consider it gets better for you, equation 2. But I try to avoid big number like a 12. So S3 times 3, so you replace x for 3 minus 4y equal 1. Okay, this is 9. So for y is 1 minus 9, no? -4y equal -8 divided by -4 both sides. Y is equal to, and the solution set is a point, unique solution, is the set formed by 3, 2. Okay. If you want to see graphically, you put in decimals, why not? Let me try. Wait. Here. Okay. Okay, switching. Decimals. Okay, it's example 4. Do you see this one now? Example 4, look at that. Example 4, we have 3x minus 4y equal 1, 2x plus 3y equal 12, and the solution that we get in the paper was 3, 2. Boom. Let me see what's going on. Oh, there you go. Make it zoom. So the black equation was equation number 1. The red equation is equation number 2. And the common point, the intersection is 3, 2 point. Is the solution. End the story. Any question 2D? Do you understand very well 2D? Do you understand very well 2D? I promise I want to complicate a lot of this. This is 2D. We study after 3D. And the test number two until 3D. From the test number 3, we expanded 4D, 5D, and so on. But we study a special technique to manipulate this. Okay, guys. Now, before 3D, not 3D now, let's move on. Let's move on to the application. What is the application? And the real life or the linear system of equation. Well, we have, I can put infinity example, but I select 2 examples of the application. Look at that. Boom. 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 Do you see the PowerPoint? Do you see the PowerPoint? Do you see the PowerPoint?
Yes, sir.
Okay, copy the problem, please. It's the first one. It's perfectly matching with the disease we have, the situation we have right now. COVID-19. It's about hospital. A hospital uses 15% bleach solution to disinfect a quarantine area. How much 6% bleach solution must be mixed with 18% bleach solution to make 50 liters of 15% bleach solution? A typical mixed problem, and where you mix 2 solutions and you want to expect to get one specific solution that's good to disinfect, in this case, the quarantine area. Let me know when you finish to copy. Done? You finish? If you want, today I sent to you this PowerPoint, no? I sent by email or no?
You sent the link.
Yes, I got the email.
Okay. I don't remember. I forgot the thing. Okay. So I sent to you by email. Okay, nice, perfect. Okay, good. Then you can open your own computer if you want. Or you copy in the notebook now, whatever. Let me try to come back to the board. Okay, it's my board. Let me erase everything in my board. Good. Okay. Let me try to understand. We have one container maybe here. Suppose one container. We have solution whose its concentration is 6%. And we have another container. Here the solution is 18%. Because I need the last container. That contains specific 50 liter is a volume and 15%. Okay, you mix this and this together, plus, and you give me that. Let me try to understand if my question has sense or is stupid. So it's logical because you mix it 6% and 18% in different proportion. Of course, you get 15. It makes sense or no? Make sense? Make sense or no?
Yes, sir.
It makes sense. Suppose I change that number. I put 20%. This problem is possible or impossible?
Not possible.
Not possible. Okay? But normally, we expect always in the concentration, in the final concentration, one intermediate value in between 6 and 18. Make sense, right? Entonces, I don't know how many liter of this. Entonces, I call X X represent the liters I need to take of this and put inside it. Okay? And Y is the liter of it. Entonces we have two equations, no? The first equation is obvious. Is X plus Y equal 50. Because basically we adding, it's important, guys, in the equation you're adding liter, okay? Kilometer, time, hour, the same unit, because it's addition, no? We cannot adding kilometer and meter. This is wrong, it's impossible. The first equation is the volume of this container plus the volume of this container give me 50 liters, que es this volume that we need for this. Okay, but I try to understand what represents 6%, 18%, and 50%. I have no idea. Okay, when you say one solution is 6%, that's mean que 94% is just water, pure water, and the rest 6% represent the bleach, pure bleach. Okay, this represents 6%. In this case, more concentration, we have more bleach here, and we have intermediate value. Do you understand this idea? This idea is cardinal to understand this. Wow, what the hell is this? Do you understand what means the concentration or no?
Yes.
Okay. Okay, entonces I propose you set up one second equation, but this second equation is just bleach. Okay, this was total volume. But in the second equation, no, it's only bleach volume. Entonces, how many liters of bleach we have here? How many? How many? What is the formula to compute this? 6%. How many? How many bleach inside here? You understand that 94 is water and 6 is bleach, right? So what is the formula? The formula is 6? No. It's 6 times X. Oh, actually, it's 0.06X. Make sense or no? Make sense or no? What's confusing?
Substituting that for the percentage.
Absolutely. When you want to find in the percent problem, you multiply the decimal times the total and give me the part. And that part represents bleach volume. Likewise, in the second container, we have 0.18Y equal, In the last one, we have no variable, we have just number to say 50. So 0.15 times 50, no? Put in a calculator, it's 7.5. 7.5. 7.5 what? What is the unit of this? What unit? Strawberry, peach, kilometer, hours. What is the unit of this?
Liters.
Liters, very important, liters. It's extremely important to make sure you understand the problem when you understand the unit of the problem. And this is my system, guys. And this is my system of equations. So don't expect that when you solve the system, understanding the problem, you get nice equation. Nice. No, ugly, nasty, horrible. And you manipulate now using algebra. But in this case, it's extremely easy because I don't know you, but I don't like the decimal. If you multiply the equation number 2 by two places by 100, the entire equation number 1 by 100, we have 6x plus 18y equal 7500. No, 1, 2, 1, 2. No, it's too much zero. It's, yeah, like that. Oh no. is 1, 2. So when you multiply by the number ending in 0, you move the decimal place to place it to the right because of multiplication. Okay, and so this is my solution. This is my equation. Let me go being elegant way now. This is my system. Equation 2, equation 1. Ready to apply. To apply what? What do you recommend me? Substitution or elimination? Recommendation.
Substitution.
Exactly. Why?
Because you have a positive one variable.
Exactly. Okay, then I don't know the way that you are doing, but I am doing one way. I need to make a decision. I take the easier equation, get the equation 1, get the coefficient is 1 and 1. I solve for y. I solve for y. Another student maybe solve for x. And substitution is expressed where? Where? And then another equation, no? And the y place, here. In the y place. Entonces es 6x plus 18 something, paréntesis, 50 minus x is equal 750. To apply, distribute the property. 6x plus, let's put in my calculator, 18 times 50, 900. Minus 18x equal 750. We combine like term. We combine like term. This is 18 minus 6 is 12. Actually, it's negative 12. I move 900 to the other side, like a minus 900, and use subtraction. 900 minus 70, 750, 150, pero negative. Negative 150. Finally, I divide by negative 12 both sides. Yeah, I put in my calculator. X alone is equal to 150 because negative divided by negative is positive. You divide by 12, and the answer is 12.5. 12.5. 12.5. So in the middle of the algebra, I forgot exactly what are you doing. Calculation x and x. What's the unit of the x? Unit. What is the unit? Liters again. Perfect. Yes, liter. I need to put together 12.5 liters of the solution. Okay, by the way, let me recall the solution X is the solution that contains 6%. I need to put here 12.5 liters. And the rest is Y. Ooh, it's super easy because I subtraction 50 minus 12.5 is 37. 37.5 liters. End the story. Okay. This is perfect. I like that. Good. But I want to verification. This part is not mandatory, but it's in my opinion, good. Okay, in order to check in the solution, the solution was this and this. Use substitution, recommend substitution, not in the elementary first example, because it's straightforward. You know, in the complicated equation, that is number 2. The equation number 2 is 6x. Yes, I verification is 6 times 12.5 plus 18 times 37.5 should be equal 750, no? 750, okay. That number, right? Look at that. In the equation 2. That number. Okay. Again, I put in my calculator. In my calculator, I put 12.5 times 6. 75. 18 times 37.5. 67, no, 6 600. Ahí. 675. And together, adding 750. Okay, this is checking. This is the no mandatory. If you feel comfortable with your answer, you don't need to check it. But I like to check it. Any question in this problem? Easy. You remember in algebra that problem or no?
Yes.
Okay. I bring another. Another word problem. Guys, you have to solve it in the homework word problem. So read. You need to read the problem. You need to understand the problem. You need to set up the equations. And after you apply algebra for solving this. And finally checking to make sure that your answer is good. Let's come back to the PowerPoint. And the PowerPoint, and the second slider. Okay, wow. And the second slider. Share PowerPoint. I have this situation. Okay, please copy. Oh, you open your PowerPoint and you can see the problem. Okay, I give you 30 seconds to copy that. A riverboat traveling against the current take 3 hours. To travel 24 miles. So the distance is 24. The time is 3 hours. The return trip downstream, because we have a current, no? When you travel against the current, I suppose that you are doing low, because you need to overcome the current. But when you travel down the stream, the current is in your favor. Therefore, you go fast. And the same distance is 24 miles. You travel in only 2 hours. Find the speed of the boat in still water and the speed of the current. Super. You got it? Do you understand the problem? Okay. Now you understand a little bit. I go to the board. I erase my board. I want to show you the board now.
I don't see the board yet.
No, I know. I suppose that you see now. Okay, let me make it zoom out. Entonces, I have no idea. And the other problem, I do the sketch of the container, no? But in this case, no container. In this case, it's a board, no? The board look like that. Look. Wow, I like this board. I have the same. I try to make the same. Okay. Entonces, I call my problem talk about velocity. So what is the quantity we have? We have mileage is distance. The distance, by the way, is always the same, no? Because it's the same trip in opposite direction, but it's the same. It's 24, no? 24 miles. The time, no. The time is different. The time when you go against the current is 3 hours. And the time, this is again the current, again. And when the time when you go in the same direction, so forward, is 2 hours. So my problem talk about the and what about the speed of the boat? I have no idea. Speed. I suppose now this is the moment to introduce variable. XY, XY. I suppose que X is the speed of the ball in still water, no water, no water. But I put the water now, for the water in that case is against the upstream. So the current is in opposite direction. So this is upstream. Yeah, I call Y. And Y represent the velocity of the current. Okay? In this case, no, it's the same direction because it's down the stream. Okay? Okay, let me summarize the quantity. And finally, let me try to set out the equations, no? The quantity that we manipulate is speed. Another is distance. And another is time. And you have two situations, no? Situation up, like this, and situation down, like this. No? Let me try to compute the speed. Okay, the speed, the time first. Okay, not necessarily, it's just copy. It's 3 hours here, 3 hours, and 2 hours, because I go fast. The time is smaller. The distance is the same. Yes or no? And I have to remember one easy formula in physics. The speed is the division distance divided by time. You remember this or no? Elementary physics. Physics without calculus. You took or you never took? Okay, I suppose you have to take. But you remember this, and somehow that formula using the common sense, no? No, no common sense. Distance.
Yes, it's common.
Yeah. When you travel 60 miles per hour by a expressway, that means in 1 hour your distance that you travel is 60 miles. 60 divided by time. It doesn't matter que actually it's 1 mile or 60 miles, 1 hour or 2 or half an hour, pero es the formula. Entonces, the formula is you divide 24 divided by 3 is 8 miles per hour. And 24 divided by 2 is 12 miles per hour. I'm making sense in this quantity because look. When I go up, absolutely, because when I go up, I go slow. Down, when I go down, it's 12. The speed here is just 8, and here is 12. Makes sense. Everything matching now. Now we are ready to set out the equation. Look in this sketch number 1. In this sketch number 1, x minus y is equal 8. So the speed of the board minus, because it's in opposite direction, is equal to the total, or the net speed is 8. And in this case, x plus y, because go in the same direction, is 12. This is my equation 1, and this is my equation 2. Super easy, that algebra. Any question? What I want to solving. You understand very well? Okay.
Yes, sir.
What method of algebra you propose me to solve this equation? Substitution or elimination?
Substitution.
Substitution. Everyone is agree or disagree? Agree. The challenge is substitution or elimination?
Actually, elimination because you have a negative and a positive.
Absolutely. It's waiting for me. You adding equation number 1 plus equation number 2 by column. So how are you adding the column of the x plus x to x? Y negative, y plus cancel out. It's elimination. This is the name of the method, elimination. And a plus 12, 20. Bar by 2. X is equal 10. 10 what? What's that? What's the unit of this? I don't remember very well what I'm looking for. Who is X? Who is Y? And my problem. Who is X? What represent the variable I call X? Physical. What represents? Help me, guys, to understand the problem.
X is speed.
Speed. But what the speed? Because we have two speeds.
Miles per hour.
Speed, mile per hour, I agree. This is the unit. But this speed is the speed of the boat in still water, or is the speed of the current?
That's the current.
No, look at the sketch. I call at the beginning X and the speed of the boat. In this case, I suppose it's in the same direction. And why no? Y is to the left and this is to the right, in opposite direction. So this is the speed of the boat in still water. This is the speed of boat in still water. Do you see or no? But I need to find also the current speed. Substitution 10 in either equation 1 or equation 2, either one. I select equation 1. I don't know why. It's 10. So replace this 10 here. 10 minus y equal 8. So for y, 10 minus 8 is equal y. 10 minus 8 is 2. Y is 2. 2 again, miles per hour. And this is the speed of current of the river. Okay. And this makes sense or no? This I need to interpretation this answer is logical or illogical. 2 and 10. Look, let me show you. I come back at the beginning. Beginning. I discovered using algebra that this speed was 12. And this speed was 2. Was 2, no? No, sorry. This was 10, no? 10, coño. 10. X is 10. Let me see. Look, X is 10. In the first situation, I have 10 minus 2, is 8. Like that. In the second situation, we have 10 plus 2 is 12. Like that. End the story. We are doing very well. Any question? Any question? Any question? No,
No,
problem?
sir. Not right now.
Not right now. Okay. I promise that I want to complicate a lot of these. I warning. This is just today introduction day. Okay. Now let's move on. And the rest of the time we have to investigate the problem in 3D. This is this linear system of equation, but in 3 dimensions. In 3 dimensions, we have 3 variables, x, y, and z. Suppose this elementary example. Suppose x minus 3y plus 3z equal -4. And this is my equation number 1. 2x plus 3y minus c equal 15. This is equation number 2. And 4x minus 3y minus c is equal 19. This is equation number 3. This is the system, 3 equations, 3 unknown, x, y, and z. Okay, I want to explain the procedure in detail. Please pay attention. You selection, you pair two equations. What do you say? You pair two equations. For example, I select number 1 and number 2. Why? Because I can see this detail. Look, I see minus 3y and positive 3y. This is ready for elimination. So I copy. Look at the organization I need to see. X minus 3y plus 3z equal negative 4. This is equation number 1. Okay, rewrite again here. And the equation number 2 is 2x plus 3y minus z equal 15. The equation. And you combine this equation because I can see get ready for elimination. At least the y part. Not always is the y part. Always. In this case, yes. You adding by column is 3x. This is cancelled. And this is 2. In the right hand side, we have 11, no? Because 15 minus 47. Entonces, I want to call this equation number 4 equation. It's a new equation that I discovered that contains only 2 variables, x and z. Okay, everyone follow me so far?
Yes.
Okay. Now, you pair again 2 new equations. In this case, I pair 2 and 3. But be careful. This is not totally arbitrary. The reason que I saw que 2 and 3 is very, very convenient is because, again, it's elimination the same way. The mandatory guide, you and the first pair, you eliminate the y, and the second, you must eliminate the same. You eliminate another can know why, you are in big trouble. No, the same. I want to copy now 2 and 3. It's equation 2. Equation 3. You add them by column, it's 6x. It's a cancel. It's the same guy. Should be, must be the same. See y here and y here. This is minus 2z equal 34. Because I want to call this equation 5. And in this moment, you have 2 new equations that have only 2 unknown, that's x and z. And we have one system very, very similar to the thing we were doing before. I copy 3x plus 2 is equal 11, equation number 4, 6x minus 2z is equal 34, equation 5. We have this system now. It is also ready for elimination, no? This is a coincidence. I create this example because this example is very, very straightforward. And the rest you can see, no, it's completely crazy. But in this case, everything matching, elegant, perfect. And you can see that this is 9x, it's elimination again, and this is equal 45, no? 45. Divided by 9, both sides, x equal 4. And we get at least the first value. Okay, perfect. To find the rest, y and z, what equation you recommend me using? What equation you recommend me using? You recommend me using the horrible original equation or no horrible original equation, you know, the intermediate equation 4 and 5. What do you recommend me? The horrible original or the nice 4 and 5? What do you recommend me? What do you recommend me?
I don't know.
You don't know? I know. Okay.
I'm not sure. I'm not sure.
4 and 5. Why? Because in the original 1, 2, 3, we have 3 variables. And we have in my hand only 1. Suppose que you substitution 5 and 1, 2, or 3. So we have 2 variables. So no good. Much better. Substitution in 4 or in 5. So in my paper, I substitution in 4. It doesn't matter. The answer doesn't change. You put 5 here. So 3 times 5 plus 2c equal 11. This is 15 plus 2c equal 11. 2c is equal 11 minus 15 is negative 4. 2c is equal to negative 4 divided by 2 both sides. C is negative 2. Nice. I have in my hand 2 variables, x and c. I need only one. In this case, 4 and 5 is completely useless. We cannot use it anymore because this is the variable that we have actually. I need y. To find the y, use substitution and the horrible original equation. So I don't know why I make a decision substitution in the 2 equation. Entonces 2 times 5 because x is 5 plus 3y, I have no idea who is y, minus c, and c is negative 2, no? Be careful with the sign because we have double minus, c is negative 2, however, in the equation I plug in contain another negative outside, equal 15. Entonces 10 plus 3y plus 2 equal 15. Entonces combine la 3y plus 12 equal 15. Subtracting 12, 3y is equal 15 minus 12, the 3, no? 3y is equal 3, therefore y1. So what is the answer? What is the solution set? Well, the solution set is the triple order, no order pair, triple order. Triple order is formed in alphabetic order, x, y, z. This is a convention. 5, x is 5. Separate by comma. Y is negative 1. And C is negative. This is the answer. The answer is 5, 1, negative. The triple order can represent. Any question? It's long, no? It's too long.
Yeah, it's kind of long. It's a little confusing, Professor, but I mean, I mean, practice, I suppose.
Absolutely. Yeah, you practice. When you are doing 10 problems of this, you understand very well. Okay, and the rest of the time we have, I want to illustrate how you see geometrically this idea in 3D. In 3D, listen to me. In 3D, we cannot using Desmos anymore because Desmos is just in 2D, XY plane. We need to use in 3-dimensional plane. 3-dimensional plane contain, or plane, no space, contain 3 axes, X, Y, and Z axis. And the representation for each equation in 3D space is a plane. It's a plane. So remember, in 2 dimension, the equation is a line, 1 dimension, but in this case, 3-dimension space, each equation is 2-dimension object, therefore it's a plane. We have 3 planes, plane. So I recommend you go to the one software, it's called Geogebra. Let me show you, Geogebra. I send the link connected with this. But you don't need to be expert in Geogebra because Geogebra is using in Calculus 3. Geogebra Classic. There are several options we use in Geogebra Classic. Let me try to show you in the rest of the time, we have 5 minutes. Geogebra, you go to your browser, Google Chrome, maybe, I don't know exactly, or whatever. You go to the Geogebra Classic. Okay, you create an account or not necessarily account. I have my account. Look, this is my account. Let me show you. Let me switch into Geogebra. Screen switching. Geogebra. Look at that. Geogebra is to graph it in 3D, guys. Look, this is my name. You know my name, no? I have 3 examples. Bam, bam, bam. Maybe today we have time to see only 3 equations and 1 solution. Open here. Open in applications. Okay. There you go. And you see 3 axes, no? The red one is X. The green one is Y. The C is the blue one. Okay? And we have here in this corner, I don't know, you see very well or no? Do you see Geogebra or no? Do you see or no?
Yes, I do.
Yes, okay.
Yes, sir.
Look.
Yes, sir, we see it.
Okay, good. My first equation was X minus 3Y plus 3Z equal -4. Boom. I put here. I put enable, and you see what the line? No, it's a plane. Look, it's the blue plane. It's a blue plane. The second one is 2x plus 3y minus z equals 15. Yeah, it's a red plane. Okay? And the second one is 4x minus 3y minus z equals 19. It's a green plane. Actually, I can rotate. You want to see because in 3D you need to rotate to see. And the solution point we discovered using algebra was
That's
5.
cool.
Say again.
That is cool.
Super cool. But
Yeah.
this is just the beginning, sir. Look at that. And the solution is the point 5,1 negative 2, que is a point they put in black color. Look at that. Do you see the solution in black color? Do you see the point solution? Let me show you. Suppose que remove green, remove this, and remove that. This is the solution, the point A, que 5,1, negative 2. It was the intersection between first plane, second plane, and third plane. The common point in between that plane is the solution. But what is the problem? Always happy when you increasing the dimension for the problem in mathematics is more complicated. And you can see more possibility. But more possibility can complicate your life. So this is the most straightforward elementary example in which you have one solution. The solution was the common point between 3 planes and the space. Okay, 3 planes, one solution. Okay. I suppose it's enough for today. Let me take advantage to repeat again. Okay, I need today. You see my face? Good.
Yes, sir.
I need guy today receive test on paper and you submit the test online. Good? Correct? Any problem you have, any emergency you have, you need to communicate with me in private. Okay? I evaluate the situation. I consider it okay. Extending a little bit, no.
Okay, Professor, whenever you chance, can I talk in private? Giovanni Grimaldo, sir.
No, in private. You email me and communicate with me by email. Okay, any situation that you have. Okay? Bye.
Thank you, sir.
Pleasure, as always.
Thanks, Professor.